Hi everyone. So, welcome to the class. So, in the last lecture we did a hands on experience or hands on exercise with LDA, right. So, we learned how to conduct an LDA for topic modeling, and we also learned about how to write the codes and how to practice that, right. That is what I had shared with you, the codes also. So, today we will continue with that, right, topic modeling, the next method of topic modeling, which is non-negative matrix factorization. So, NMF, right. So, how would you conduct NMF into that is the basic idea of today's class, right. So, on Jupyter Lab, so you can, as last class you did that. So, similarly now also you start the Jupyter Lab with me, open up, and without wasting any time, let us get into the exercise. Okay. So, let us start. So, if you go to this file, right, so NMF file, so here we start. So, first thing that we are talking about is the same old codes, like for example, import pandas as PD, right, import numpy as NP. So, these are same thing, I am not going to discuss much. So, like you did in the LDA exercise. After these two codes, you have to come to the third code, which is the from sklearn.feature, this code if you see, right. Now, this imports the TF5 DF vectorizer class from SC skitlearns feature extraction text module, right. So, it basically what it does, so sometimes these are tongue twisters, difficult to pronounce also. So, do not worry, it converts a collection of raw documents into a matrix of TF-IDF features. TF-IDF, if you remember, right, term frequency, inverse document frequency, we had done it in the one of the classes in text analysis, and we had learnt how to even make the calculations for it. So, it does basically that, right, converts that raw documents into TF-IDF. Next is we go to the decomposition import NMF. So, this code, right, this is a very important code now, because this is different from LDA. So, this code will import the NMF class, non-negative matrix factorization, from skitlearn's decomposition module. Okay. So, as there you are importing the LDA module, here you are importing the NMF module, right. Now, this is used to identify again the same topics in the text data. So, the use is almost the same, but the method is already learned that it is different. LDA was used a probabilistic approach, and this is using a linear algebra approach. Okay. The next code is import matplotlib. So, this one, and what is its purpose? To create plots, for example, line plot, bar chart, scatter plot, histogram, all these things. Okay. Then we get this code from word cloud, import word cloud. Now, again the use is almost the same that you have done. So, it will help you to make a word cloud, right, and what is a word cloud, that also we have discussed in the LDA class. Next is go to import OS. So, this imports the Python's built-in OS module, right. So, that operating system which provides functions for interacting with the operating system, such as working with file paths and the directories. Okay. Now, what we will do is we will load the Excel file. Now, you remember the Excel file we had given the name TA2. Okay. So, that Excel file we will load in this step. So, the code we have written is input underscore file path is equal to ta2.xls, right. Then we are saying df is equal to pd.read. So, this line reads the Excel file and helps in the further analysis. So, the resulting data is loaded onto a data frame called df, and which is table like structure with rows and columns, okay, ideal for data analysis. After this, what it does is basically drops the rows which is empty. So, this comment explains that if there is anything missing or empty, that will be filtered out or removed. Okay. After that, the next, if you see, it also says drop NA, if you can see that one, right, that code. This selects only the processed comments column from the original data frame and drops any rows where the value is in that column is missing or null, right. It is the same process that you have adopted in the LDA exercise. Now, this is typically used to clean the data set before applying NLP techniques like TF-IDF, NMF, or doing sentiment analysis. The next code here, if you see df underscore filtered, this last one, right. So, what it does basically is it further filters the data frame to remove rows where the value is an empty string or contains only white space. Right. So, there should not be any empty string, any white space. So, all these things have to be removed. So, str.strip removes any leading or trailing white space, and S type bool that converts the string to a boolean value, right. So, it becomes false if the string is empty and true otherwise. So, whole line keeps only those rows where the clean text is not empty, right. So, in short, basically this step ensures you only keep rows with meaningful non-empty comments for analysis. Okay. The next code that we are writing here, so right. So, vectorizer. Now, this helps us, this tells that the next lines are about converting text data into a numerical form. So, vectorization, if you remember, we have already learnt how NMF has a long range of data. So, which is used for vectorization, right. Even BERT also, in BERT we are using that method. So, here we are saying, so text data is converted into some numerical form using TF-IDF scores. Okay. And it uses, this helps to identify the most important words in the document. So, the as per the value we can identify which words are most important in the document. Next is the this code, which is again like that code in LDA, where it says that ignore the words that appear in more than 95% of the documents as they are too common, and include only words that appear in at least 2 documents, right. So, filter out the rare words also, and automatically removes common English words like the, is and. Okay. So, after all this, the vectorizer is now ready to convert text into a matrix of TF-IDF features. Okay. After this, we go to this code which says TF-IDF underscore matrix. Now, this one, yes. Now, this line applies the vectorizer to the processed comments column. It does two things basically. It learns the vocabulary and IDF weights from the data and then transforms the text into a matrix of TF-IDF features. Okay. The resulting matrix is a numerical representation of the text data, where each row corresponds to a comment and each column to a unique word or term. Okay. Now, this is the matrix we will use in our next step for our topic modeling. This is where the raw text becomes numeric data and the machine learning models can understand it, right. Okay. So, now let us go to the next code. So, in the next code, right, we are assigning a topic of 5. So, n is 5. So, this sets the number of topics you want NMF to find in your data is 5, right. So, 5 distinct topics will emerge. Now, after this, the next code says NMF underscore model, this one. So, again like the last one in the LDA we have done this. So, it helps us to ensure reproducibility, right, the same thing will be repeated. Okay. Now, the next code says NMF underscore features. So, this line fits the NMF model to the TF-IDF matrix and transforms it, right. Basically, it fits the MFF model to learn topics from the data. So, the fit underscore transform that learns the topics and assigns each document a distribution over those topics, transforms each document into a vector of topic scores, right. So, that is basically it says how much each document relates to each topic. The result that comes out is a matrix where each row corresponds to a document and each column represents how much the document relates to that each topic, right. So, two things. So, how much does the row correspond to a document and how much does each column represent, or how much the document relates to each topic. Next is that we go to the topic assignment and keyword extraction. So, the topic, the keywords, this comment indicates that you are now identifying which topic each comment is most associated with, and then extract the top keywords that define each topic. That is the whole purpose of topic modeling, right. Now, this line topic underscore assignments is equal to this code, this assigns each comment to the topic it relates to the most. So, NMF features is a matrix where each row represents a document and each column represents a topic, right. And AR.ARG max, now this one finds the index of the highest value in each row, that is the topic with the highest weight for that document. Okay. Next, so topic assignments will be a list where each element is the number of the most relevant topic for the corresponding comment. Now, we go to the topic keywords, top keywords. So, this initializes a empty list named top keywords. Later, this list will be filled with the most important keywords. So, first a column will be made and then the keywords will be there, right. So, for each topic, the words that define what each topic is all about. The next code is feature underscore names, this one, right. Now, this retrieves the list of all the unique words that the TF-IDF vectorizer has learned from the text. So, that is what it has helped to convert into numerical. So, these are the actual words that correspond to the columns in your matrix, and they will be used to identify which words are important in each topic. The next code is for topic underscore IDX, this one, right. Now, this starts a loop to go through each topic in the NMF model. So, NMF underscore model, this one is a matrix where each row represents a topic and each column represents a word, right, corresponds a word to a word. The values represent the importance of each word to the topic, and enumerate, this bracket, this one, this gives both the index of the topic and the topic data itself, right. So, what is the topic, which is basically a vector of the word weights. Okay. After this, after you have gone through this, then we go to the next code. So, top words is equal to this one feature. So, this line identifies the top 10 words for a given NMF matrix, right, sorted by their importance as per their weights. So, the topic dot argro sort, now this one if you see, this returns the indices of the words sorted by their importance in a ascending order, okay, from lowest to highest. Then this one, the bracket where you have written that calls double dot, then 11, this one slices the last 10 indices in descending order for the top 10 highest weights. Feature underscore names then converts these indices into actual word strings, and the result is a list of the top 10 important words for the current topic. Okay. The next code, top underscore keywords underscore append. Now, this adds the list of top 10 keywords for the current topic to the list you have created earlier. Okay. So, the top underscore keywords, we have created a list, no. So, there it will be added. So, it adds topic scores and topic as to filter the data frame to the filtered data frame, right. So, this comment indicates that you are now going to add the NMF results, the topic scores and the dominant topic information as the same process in LDA back into your filtered data frame. So, for that we need this code for I in range n underscore topic. This starts a loop to go through each topic index, and the goal is to add each topic score to the data frame as a new column. And this code, this line adds a new column to the data frame named topic underscore 1 underscore score, right, and similarly topic 2, etc. So, this dynamically creates the column name and selects all the rows for the ith topic column, meaning that the score of that each document or each comment got for that specific topic. The next code adds a column that shows the dominant topic with the highest score, right. So, this information comes from the topic assignments which you created earlier using your argmax, that code, right. Then you go to the next, this last one. So, here this line says that it adds a new column to the data frame that contains a comma separated string of the top keywords for the dominant topic of each comment. So, for each row, topic refers to its dominant topic, and top underscore keywords gets the list of top 10 words for that topic, okay, and that join converts that list into a readable string. Okay. After you have done all this, now we will create a local output folder if it does not exist. So, so the comment will be loaded, will be saved in a output file. So, what we give the comment, the code sorry, is output underscore folder. So, this one. Now, this sets a variable named output underscore folder with the value NMF underscore results. So, this is the name of the folder where you plan to save the results for your analysis okay. And then os.makeDirs. So, this creates the folder on your computer if it does not exist, and it is a function, basically os.makeDirs is a function of the operating system module that creates directories basically, and it tells Python not to raise an error if the folder already exists. It just keeps creating it again. Okay. The next thing that we come to is the save word cloud, or to create the word cloud and save it. So, this comment tells us that the following code will generate and save word clouds. Okay. So, this initializes an empty list called word cloud paths. It will be used to store the file paths of the saved word cloud images, which is useful if you want to reference or use them later. Suppose you want to refer it later, So, that will be stored and you can use it later on. This code then says for IDX, now if you can see, this starts a loop that goes through each topic's top keywords. Okay. So, you see enumerate this bracket top underscore keys gives you both the index and the list of keywords for each topic. The next is WC is equal to this code. It creates a word cloud for the current topic. So, it initializes the word cloud with a white background and a specific size. The next one path, right. So, this when you write this code, this builds a full file path where the word cloud image will be saved, right. So, what it basically does, it combines the folder name with the file name that works on any operating system, and it creates a file name like word cloud underscore topic underscore one dot png, something similar to that, right. Then this WC, this line, this code saves the generated word cloud image to the specified path on your computer, and the next line, it adds the file path of the saved image to the word cloud path list. So, you have a record of where all the word clouds were saved. Okay. The next step is to save the entire file, to save this to Excel. Okay. So, to do that, we have to give this code output underscore Excel underscore path. Now, this sets the name of the Excel file you want to save the results to. So, it is just the file name, right. And then when you write this code df underscore filtered, this entire one, this line saves the filtered and enriched data frame to an Excel file, right, and then it creates the full path by combining the folder and the file name. So, index is false means the data frame's row index actually will not be written into the Excel file, only the actual data will be saved. Okay. Now, we will go for the output Excel path. So, this code, right, this line returns or displays the values of the output underscore Excel underscore path, and this is the name of the Excel file, and it is the list of the paths to the saved word cloud images. So, if you are running this in a Jupyter notebook or script and want to confirm where the files are saved, it is useful. The next is show top words, to show top words and the word clouds for each topic. So, this comment, right, also tells you that the upcoming loop will display both the top words and the word clouds. So, now if we go to topic IDX, that is the code, this starts a loop to go through each topic. So, which gives you both the topic and the array of word weights for the topic, and each topic as we know is a vector showing how important each word is to that topic. Then we will print it. So, this prints a nicely formatted header for the current topic, making it easier to read and separate the topics in your output. The next is top underscore indices, this line, this code. This gets the indices of the top 10 most important words for the topic, right. So, it sorts the word importance scores in ascending order, reverses it to descending, slices out the first 10 indices, that is the top 10 words. So, now we are coming towards the end. So, for this code for I in top underscore indices, this begins a loop to go through each of the top word indices for the current topic. Now, we will give a print code, so which is this one. So, this prints each word and its score in the current topic. So, it gives you the actual word, formats the word's importance score to 4 decimal places, and the next code says, this creates a dictionary where each key is a top word and the value is its score. Now, this is needed to generate a word cloud based on actual weights rather than the frequency. Okay. And the next one, word cloud, this one initializes a word cloud object with white background and a specific size for display, right. So, you remember this we had given in our done the same process in LD also. The next one is generates word cloud. It generates the word cloud using the weights in top words, right. So, that is the word importance as frequency, and the next few lines they help you to create a new figure with maybe 6 to 3 inch size and display the word cloud image with smooth rendering and hides the axis. So, that plots looks clean and image only, and then it adds a title, this one above the word cloud to show which is the topic, which topic is being displayed, and finally, this displays the word cloud in the output. So, perfect for a visual understanding the essence. So, After all this, you can, what you can do is again go to this file and see what are the top 10, top 5 topics that have emerged. So, the topic 1, top 10 words with their scores, similarly, and this is the word cloud. Topic 2, again the 10 words and their scores, right, and the word cloud, similarly 3, 4 and 5, right. So, now what you can do is, if you have seen all these 5, you can go to the file where we have, we can, yes, we can, we have downloaded, I think we have somewhere. So, we can see this. So, we have, with the same file, we have also worked on LDA, we have now worked on NMF, right, and we can see. So, the top keywords are also coming here. So, everything is given to us, what is the dominant topic. So, last, if you remember, so in the same file I can show you both the files. So, first let us see this one first, right. Let us go to the NMF file only and go back and see. So, the first file, the dominant topic is 4, 4 means the topic 5, okay, and the top keywords are given to you. Similarly, in the second one, if you see, the top keywords are, dominant topic is the second, that means the third D, column D, right, and these are the keywords, okay. Now, let us go to the LDA file and see what were the dominant topics in that. So, dominant topic for the first row was 0, that means the first topic, and here in this case what we are getting is the fourth one, right. So, we are getting different results for both the topics, right. You can see 4. So, there is a difference. So, as per this file, if you can see the NMF file, here for this tells us that the fourth, that means the fifth topic is the most dominant topic, right. So, there is a difference. Now, what you can do is, maybe you can randomly search through some documents or comments and see for yourself which do you feel is more practically relatable, right. The LDA model is more relatable or the NMF one is more relatable. You can cross check, cross verify that with your own knowledge and your experience, and maybe you can then say which is a better output, giving you a better output, LDA or NMF, right. But the purpose is different, right. LDA works on a co-occurrence of words approach and NMF is a different approach, right. So, it is working on a different mechanism, but whatever it is, finally you can do the comparison and check for yourself, right. So, I think you have understood at least how we can conduct a NMF approach for topic modeling, and I think you can go through it, rehearse again and again and check it, and so that you can work on different kinds of topics and get lovely results which will be good for your research. And with this, I think we have added some new knowledge today, and in the next class we will work on one more method, and till then take care and thank you very much.